I want to say a little about the research that went into this presentation. It helps bring together our offices in a way that offers a lot of redundancy and intelligent routing, which is well, of course it's a key goal. You want that kind of redundancy in your system. But without a protocol like DUNDi playing a part, it would be much more difficult and actually a lot less optimal as well. So this is actually kind of a very high-level overview of how a widely distributed PBX solution would operate out there in the wild somewhere. And I hope you guys take away something from it, from a lot of the R&D that I've put into it, as well as a few other people here who've spent a lot of time, especially at Digium, developing DUNDi, making it work, and getting some word out there on some fun things you can do with it. How many of you guys operate Asterisk, administrate Asterisk systems? Awesome, thank you, God. All right, and even if you aren't, it should be pretty easy to notice the differences between a typical canned approach for implementing a phone system as well as having like a hot backup sitting around to help deal with emergencies. So without further ado, let's get started. What is DUNDi? All right, it's right there in black and white. Distributed Universal Number Discovery. I don't know. I actually have no idea what the I stands for, and if anyone does know, come on up after the presentation and tell me. I'll owe you a beer. If you don't know, if it's completely incorrect, you owe me a beer. DUNDi is simply put a clever way of distributing which nodes have which extensions available through it. It's a very, very clever advertising system, and I really like it. So we use DUNDi to help create an interwoven network of computers called a mesh, which is kind of coming up on the next slide for a little visual reference. All right, so this drawing represents 6 DUNDi-enabled Asterisk VoIP servers, or nodes, that each act as a local phone system for a company branch, specifically our company branches. Each square dot represents an endpoint. It's actually kind of simplified, but I like it. It's pretty. So my wife says, "Ooh, a star snowflake." But that's really what it is. You want all these systems kind of talking to each other. So the gray lines in the middle represent both a DUNDi advertisement network. Each one of these nodes knows about the other node, as well as direct SIP peer-to-peer access between them in order to allow for kind of direct communication. Yeah, our original cluster, we used Sesame Street character names during testing and during the first rollout. It seemed like a fun idea to use these in the diagrams. So we have Oscar, Bert, Ernie, Big Bird, Count, Von, Count, and then of course everyone's favorite Cookie Monster. Even though this is a mesh of services and it will automatically discover kind of what's happening between them, it doesn't mean that we don't have a lot of control into how they respond to certain events, which kind of makes this approach really fun. We can actually target which machines back up other machines. We can target which machines handle specific routes. And so it's hopefully get that from the diagrams that I'm going to present in a bit. All right, warning, DUNDi ahead. There's some important tidbits about DUNDi to keep in mind as we proceed. Like partially connected nodes will still have their extensions relayed through other connected nodes. So Ernie can essentially respond for Bert, even if no one else can actually communicate with Bert. And there will be no weight difference, there will be no penalty, there will be no anything. It just simply looks like Bert still exists somewhere out there on the network. So we need to compensate for that a little. Also, you should always use common names or common IPs for peer connections. So if Bert says, "Hey, I'm SIP Bert," everyone should know where SIP Bert is, or at least have a peer definition for SIP Bert somewhere. There's a few things to remember when dealing with a lot of nodes. So this is like 20, 30, 40. SIP X headers are your friends. So this is not necessarily related to the amount of nodes that you have, but reducing the complexity when you start handing calls around. So you can store them with your CDR to help follow a call around. So if you generated a unique ID, which the SIP channel driver automatically does, you kind of want to know more about that. You want to pass that along as calls go from node to node. in the end, let you know how the call went through your system as kind of a breadcrumb. And you can make this kind of a linked list. You go from one to the next, to the next, to the next. It's pretty fun. You can also use them for all your extra information. We use them for all sorts of things. Our SIP headers are probably a book by the time they get from one machine to the next. And that's because we do a lot of database lookup, stuff like that, before we send the call off to the next node. This is typically from like what you consider a SBC, something else like that, handling inbound calls. So we put a whole bunch of information in there: the department name of the called party, all sorts of. I can go on and on. But we also use it for our ticket number system, and to put a ticket number in for any automatically generated tickets that are going to follow this call around, as well as kind of a queue priority. If we have a call come in and one of our contact center agents decides that this needs to be escalated and the queue is somewhere else in the world, we can go ahead and say, hey, this needs to be escalated as a SIP header, pass that along, and then when it gets to the other machines, they know what to do with it. It's very important, of course, to have a good testing environment. These two up front actually have virtual instances of Linux. I have an i7 laptop that we got for like $800 in a sale. It's got 8 gigs of RAM. I can virtualize dozens of machines. It saved us a lot of money. I could, of course, be just doing this directly on production machines, but that would be bad. And also, have a good Asterisk consultant on the hook somewhere. They like to help out with stuff like this. They like to take your money, stuff like that. It's a really good to have a backup when you're actually doing kind of a long-term deployment or a very large deployment. All right. Our goals for a distributed or wide area mesh network at Microcom were, of course, have as high a quality as possible, but let's just start off with kind of a smaller list. All nodes attempt to connect as directly with other nodes as possible, and we do this to establish the lowest latency RTP path possible. We do it to have less call hops. We do it to have less log noise. And our goals for a distributed wide area, reading onto my notes here. So what this really means is, as we go through different servers, we're of course adding latency to our network, and that's actually no good. Reducing log noise is very important too. If you're actually pushing all those logs somewhere, you don't want a whole bunch of redundant information as well as higher latency. Kind of show you kind of an initial query real quick of what that means. So Cookie Monster is here. He wants to know who has an extension. So one of the endpoints on Cookie Monster wants to know where another endpoint is. So it sends out a kind of a global query. It wants to know what's up. Bert responds. It says, I actually have that endpoint. So let's go ahead and just make that happen. And the call connects and everyone's happy. How exactly did that work? We have the DUNDi PBX switch statement, which kind of steps through. It's a good shortcut for iterating through the results until the call is actually completed. That's not very redundant. It steps through one at a time. It's not necessarily a solution I was looking for. DUNDi lookup is definitely not. It only returns one of the lowest weighted results, which does not offer any redundancy. And then these two, DUNDi query, DUNDi result, they work as a team. First by creating a list of results and then allowing us access to them in any order that we want. You can randomize them, you can put them all together, it doesn't matter. It's very useful when you want to have a lot of control over how the calls are made. All right. Some nodes configured to back up other nodes. High reliability for close nodes. So let's say Bert and Ernie live together. We all know they do. And if Bert can't hear us, Ernie can proxy our call, like through the window or something. But it's an opportunity. It's there, and it can help Bert stay in touch with those who need to reach him. We are required, well, I say we're required to proxy RTP. Never assume that an unavailable node still has an RTP signal path to any other node. Or rather, just don't assume any node has access to any other node. If you're acting as a backup for any reason, you should actually proxy that RTP just to make that call absolutely 100% complete. And of course, weighted backup servers to make selection a little bit more intelligent. So in Bert and Ernie's case, they would actually have the lowest weight when they're advertising that backup route. And that makes it a lot easier for everybody to understand the best route decision to make. All right, let's go ahead and look at that. So this is kind of that backup connection. Cookie Monster said, hey, I know Bert has this. Let's go ahead and call him. Some reason, faulty wire, Bert on the wire, whatever. Cookie Monster to Bert is not going to work. But Ernie said, hey, I actually have a backup route for this, so I'll go ahead and proxy that call for you. So how exactly does that work? SIP Bert extend is returned by DUNDi result, and then we attempt to dial. And that's kind of just how DUNDi returns information. It's SIP whatever, and then the extension that you're actually looking for. Now on failure, we're actually going to query for SIP pound Bert pound extension to actually make it kind of a compatible dial string that we can use. So as an example, on Ernie, there's your extensions. I don't know if everyone can see that at the very bottom there. And it's saying, hey, I actually advertise for SIP Bert whatever, and I'm going to go ahead and proxy this call over to SIP Bert directly, since obviously you had a hard time doing it. And then, of course, any machine that's using backup routes, once a backup route is advertised, you should continue going on and on through the result list. Don't bunch them together, just go one after the other until you actually get that connection made. That allows you to have multi-levels of backup. All right, let's take a look. So we want to allow identical extensions per node. A little history. So historically, my company, we've had people unplug their phone in one state and bring it with them to another office in another state. Has this happened to anybody else? Okay, and it should have just worked, right? All right, hopefully it did work for you guys because you're super awesome and you can make all that stuff happen. We also have people with multiple offices and dedicated phones for each office, which is becoming more and more popular situation, even though we have mobile phones in everyone's pocket. What this does is, or at least having this sort of mentality plugged into our solution, this allows us to have roaming or hot desking between sites pretty easily. We advertise extensions, they suddenly appear somewhere else. This is very, very awesome for SIP and Android, or SIP, Android, and iPhone apps that just want to move between wireless networks. Your entire company has the same network ID at every single one of the locations. Why not use local resources for that call? And some fun examples, interesting examples for multiple offices. My wife, she works at a school district supporting 3 teams in 3 different buildings, and she has the same extension at every single desk. That's a situation where this would work out pretty well. And of course, construction or anything that requires temporary offices, having a manager have the same extension in his headquarters office as well as in the trailer out there in the field somewhere using who knows what kind of connection to get that to happen. That's where this really works out. Also, it's incredibly fun to have this kind of mentality plugged in. There are a lot of extra bits of functionality that you can start adding once you get creative, and I'm going to actually go over one of those at the end of the presentation. So what we have here is just the basic graph real quick, multiple identical extensions. It's worth noting that when an extension, when it registers to a node, can leave a breadcrumb in a dial plan context of your choosing. In fact, it can leave them in several contexts, even with different extensions, so that you can get pretty creative on how the paths are advertised. I'm not quite sure when multiple extensions popped in, if it was always there from the beginning, but it's something I noticed in Asterisk 1.8 when I was working on this project, and it sure is cool. I really appreciate it. So having that dynamic nature in the dial plan allows extensions to appear and disappear in the dial plan and in turn become immediately advertised or removed from the mesh. All right, so here we see Cookie Monster, is calling an extension that exists on all the nodes except for count von count because it's actually a pretty smooth setup. How does this work exactly? How do I call multiple phones at once? Well, you use DUNDi query and you iterate through the DUNDi results. And then you use dial group, which is also known as the poor man's queue, to bring all the results together into one string that you can just use past a dial and then call all these locations at once. Alternatively, there is room for load balancing, and that's part of the title of this presentation. In this situation, you can randomly iterate through the results to do a random distribution, for instance, and help you out with that. How we distribute inbound calls for a handful of calling card servers for one of our subsidiaries uses this technique. Each calling card advertises that it's part of a specific calling card line and therefore able to take part in the call load for that line. So we don't try to send it off to every single server at once and then see who takes it first. That's fraught with error. Instead, we actually kind of target one at a time, and then if that one doesn't work, we move on to the next, and we move on to the next. And that's really the power right there of DUNDi results. You get that whole list of results. Outbound calls handled properly, of course, that's very obvious. We have a big mesh, or rather a big mess of IP addresses now. We're going to be calling out through a smaller set of external providers, of course, to do a lot of this if we use voice over IP providers for our long distance. So your long distance SIP provider typically isn't really going to appreciate having that many devices for your single account, and you'll probably want to create a more common entry point, which I'm going to go over in a bit. Yeah, it's if you get charged per device for each one of your nodes, if you get if you have a firewall difficulties communicating in with the server, you really want to control that somehow. So this is just kind of a reference. BERT, of course, originates a call. Once I send it out through the outbound provider, it knows this exists. Oscar knows, Bert knows, Ernie knows, Big Bird knows, and then of course I threw away Cookie Monster and Count Von Count for the diagram there. Of course, Big Bird, which for some reason has tons of bandwidth, can act as a backup. So here we see that BERT no longer has a quality connection in between itself and the outbound provider. And Big Bird's going to at least attempt to attack the call. And we can set up as many backup servers as we want by just advertising that that's there. Obviously, inbound calls, we need to have those handled properly. Inbound from any origination point, basically. Having inbound access from any origination point can cause a headache for queue management. This is, when I talk about DUNDi on IRC or on mailing lists, always queue management comes up. And I'm going to touch on that in a few moments. But we want to take advantage of information for how that call came in. And that's information that we'd also throw into the SIP headers, like the original caller ID, just in case it gets remapped from node to node. What department, if it was an internal call, made the call, and a few other tidbits that we actually use later on in our CDR. So this is a fun one. Oh boy. Here we see that the lazy admin didn't even want to configure the DID provider to know exactly where that DID was supposed to go. This is an unrealistic case, but quite frankly, if the DID provider does not offer the tools that you need in order to distribute those calls either fairly or to the correct node, it's not going to really work for you. It's complicated to say the least. All right, so let's reorganize a little bit. We may need some machines between the providers and the mesh itself to help sort things out, and we're going to call these super nodes. Da-da-da. All right, so now we have Supergrower and Super Elmo. You guys remember those guys? You guys remember Super Elmo having a cape? All right. Am I the only person that watched PBS? Are you all Canadian? Was it? All right. Anyways, so not only is this non-redundant, it's difficult to make redundant, and dynamically speaking, but it relies on tools that the DID provider provides, which I already covered. I just don't want to stick you guys into that situation, so we're going to put these guys in the middle. So it's getting a little bit more intricate now, but reducing complexity with the external resources at the same time. So now all of those guys are pushed off past on the far side of Supergrower, Super Elmo, and your mesh is now segregated. Some of you would see this as an immediate security bonus. No longer do the external nodes need to know anything about, or the external providers need to know anything about your mesh and any of the nodes tied into it, which could reduce a lot of unwanted requests, let's say that. All right, let's play. It's time to modify that diagram a little bit to show how some specific cases are handled within our mesh. So is this really a complication, or is it just simply a little bit more complex? We can deal with it. Oscar, unfortunately, temporarily, is being a grouch and won't talk to Super Elmo due to a rubbish or no good connection of some kind, and is going to make a lot of responsibility fall onto Supergrower, and that's a situation we can definitely handle. That's why we have two of those guys. And Big Bird down at the bottom there is now a high latency satellite uplink system somewhere in the far reaches of Alaska, which is very common for us to support. And due to code restrictions or specialized trunking requirements, we want to always utilize the supernodes, reduce complexity there, and always utilize those as a pathway. And then I am going to throw in a voicemail app server there. I just kind of want to demonstrate that you can have some extra components to this entire thing without including them directly into the mesh. So we're adding an app server. This can be anything, actually. I've chosen to use voicemail. Other examples may be a forwarding service or a service that simply looks for requests on the mesh. That way it's actually part of the mesh, because there's always room for Big Brother, right? You just want to make sure that everything's going on. You have a nice monitoring system, stuff like that. And then getting back to the inbound side of things, here it's actually completing correctly. We have happier inbound routing. So Supergrower and Super Elmo are, of course, the only nodes that have inbound provider that the inbound providers know anything about, and they go ahead and take care of it. They say, hey, who has this DID on the network? And Ernie says, I have it. So go ahead and call me. Now, if you guys have been to a DUNDi presentation before, a lot of this is pretty familiar. So I don't want you guys to get too bored here. So we're actually going to move into a few other areas. All right, so allow for node failure, like complete catastrophic node failure. We want to be able to completely take over for another node, probably a node that's close to us, but we could spread that out over the Y area as well. So here we are, Bert's ghost. Bert is dead, and he willed his endpoints over to Ernie, which is nice of him. Now they are Ernie's responsibility. These endpoints were configured through our own means to attempt to use Ernie as a backup registrar. And then offload services as needed. Offloading services to a specific node like voicemail should be relatively straightforward, and integrating that service into a mesh is supposed to be pretty simple. So let me just go ahead and show you a call going through the mesh right now, just from one extension to the next, and then we'll touch on how that voicemail server gets integrated. So here we see that Oscar knows that extensions 302 is on both Ernie and Bert, and is on both Ernie and Big Bird, and calls them at the same time. It's not a big deal until it times out, until we actually need to do something about it. At which point we just send out another query. We say, hey, who has the voicemail services for extension 302? Voicemail server replies, and then we just go ahead and send the call and any extra information we need in the headers in the extension itself over to the voicemail server. Well, over through Supergrower, actually, who's advertising on voicemail server's behalf, and then it takes care of the rest of it. Queues from anywhere. All right. Queues can originate basically from anywhere. That can be inbound calls, internal hotline calls, or progress through different zones. It progresses through different zones depending on the wait time for whoever called in. So what we're going to do is show you kind of a local DID that pops into Oscar up here called Street Talk. It's kind of a gossip line in Sesame Street. So the call comes into Oscar where he queries for the Street Talk local, and just to see if, well, he sees that no other node is advertising it. So we don't include any of them, and we just include our local members and then give them a ring, see what happens. Now, if none of our members answer or they aren't available as we thought they were, then we'd immediately go off to the next tier. This is sometimes kind of a poor way to handle queues, but in a distributed environment and with my actual limited knowledge of how queue provisioning works, this is kind of how we're handling it right now. But we're going to go ahead and, if they're not available, say that we're going to add another 30 seconds onto the next queue by just throwing a custom SIP header in there. And then it'll honor that and then extend the length of that duration. All right, so of course it timed out. Nobody answered locally, so we're going to move over to the district. So whoever called in was waiting long enough for that. And according to our marketing for the Street Talk hotline, it's best handled by all of Oscar, Bert, and Ernie at this level. So everybody's kind of involved. We've configured these nodes specifically to respond to this queue. It's not something magic. So we made sure that they actually have configuration for that. And then if it gets a little further than that, we actually use Street Talk Global. Any member on any queue throughout the company, any member on of the Street Talk queue at that point throughout the entire company is going to get ring until that person actually gets somebody to answer them, or it goes to voicemail. Probably noticed this works very well for ring all strategies, but requires a lot of fiddling to allow balanced distribution. So there's a few options. Number one, query for nodes. If the extension Street Talk District exists on another node, we'll call it directly, and that's kind of what I was just talking about. We actually advertise that as an extension, and we expect it to work. So the pros on that, it allows for a completely different perspective on how queue stats are done per node rather than per member initially on the origination node. And then stats per member, of course, can be collected from each individual node if it has members that belong to those queues. There's also a lot less DUNDi and SIP traffic. It's only checking out there for one extension. It's not checking for individual extensions, which can get pretty heavy when you have 200 queue members. And of course, it's a WAN. The cons, balancing is decided per node, and there's a really big con. Some of you might have noticed if Oscar only has 3 people available and Bert has 300 people available, it's gonna kind of round robin between the two. That's just incredibly unfair. But it can be fiddled with and actually taken care of. Number 2, let's query for members. So all nodes must already have a configuration for which members are in which queues. At this point, we actually go out there and say, hey, member, where are you at in the mesh network? The pros here, it's obviously more familiar than the cons. Of course, it's not as scalable as I described. You actually end up with a ton of DUNDi and SIP traffic. So least cost routing in a less traditional sense, just making use of local resources. Local PSTN connections can be used to reduce outbound costs substantially if you're already paying for them and they're not being fully utilized, especially when you're dealing with intrastate charges. We have phenomenal intrastate rates in Alaska, and I'm sure a few other rural communities. They'd rather call through calling cards, something like that, just to get around those restrictions, which is what we have to deal with up there. So if we have PRI available in Fairbanks, Alaska, Anchorage, Alaska, Juneau, Alaska, I want to make use of those if we have channel capacity for it, based on our usage patterns. Each node should present a weight for a local route that can be used for outbound calls. So if it's a local area number, I'm going to present a low weight to it so that other nodes say, or when I respond, they attempt that node first. You really want to use weights like that. In fact, you can use dynamic weights. Check out Leif Madsen's DUNDi presentation on that. It's actually pretty awesome. It describes how to use a function to respond with a weight statement that will be used throughout the mesh network. And supernodes should typically have the highest weights so that they're selected last. They're the ones that are going to be your interface between the long distance provider or local provider have it and the rest of the mesh. And so we want to use those local in-mesh resources first. And that's actually kind of all I have for you guys. I didn't know how complicated to make everything or how not complicated to make everything, but I can see a lot of you guys are actually getting along with it. So I do have some cool stuff if we have some time I kind of wanted to talk about. First is, of course, DUNDi to DUNDi routing. If you've ever used DUNDi and you've noticed that, hey, I can switch to DUNDi in my dial plan just using the PBX helper for that, you can actually advertise that on behalf of somebody else. So in this situation where we had Big Bird off in a satellite territory somewhere, and maybe we have Little Bird, the radio station over there, communicating with it, if it's not part of the mesh, we can still include it by advertising on its behalf, which can have a few errors here and there, but if you plan things out well, it actually works out pretty well. Using AMI and the dial plan functions to add and remove extensions is very similar to using simulating agents logging in and out. You can actually just use a DUNDi lookup to see if someone's on the network or not. From a manager perspective, that's pretty useful. So there's some sneaky forwarding tricks. So instead of a voicemail server, let's say we have a forwarding server set up that's set up with your DID or your extension number, and you've told it over the web somewhere that you'd like all your calls to also ring your mobile your mobile phone, maybe with some acknowledgement there so that your voicemail doesn't always pick it up. And then, of course, we can optionally tell it to always answer. Every other phone will ring, but only momentarily. The forwarding system will go ahead and pick it up and move it off to you so that way it works out to your advantage if you need that. All right, so of course this presentation was brought to you by the letters DUNDi and I and the number 4520. So after the presentation, if anyone can come up here and tell me what exactly 4520 is, what the significance is, I have a little re-gift for you. Here's some linkage for you. The DUNDi webpage, full of good information written by the folks at Digium. And then Leif Madsen's DUNDi call routing presentation. And then kind of a plug, Microcom and our subsidiary Liberty Telecom, we do consult. Does anyone have any questions about this if we have some time? I like questions. I'm not prepared for them, but I like them. All right, so be it.
Hi, can you just tell us a bit more about how you got the phones to register locally at the different offices? Because you said that you could have like an Android extension, but normally your phone has the extension number and the PBX it's connecting to. So I'm wondering if a phone's set up to talk to, say, Big Bird, how's it going to know to connect to whatever the local machine is in the office?
DNS overriding. So in each one of our offices, we have our own DNS servers, and VoIP, let's just simply say it's called VoIP, the host name, is the registrar for that. Or VoIP, we use sadio.com, so voip.sadio.com would be the registrar no matter where you are, even outside the mesh. We'd have something on the outside listening to that. So as we move from Big Bird over to Bert to Ernie, everything else like that, when we re-register to voip.sadio.com, it's actually going to be the local server instead of anywhere else. Of course, we could override that as well, just to be sneaky. That's something my boss would do. He likes to show up in weird places and just be like, gotcha. So he wouldn't use that. Any other questions? Thank you guys for coming. This is my first presentation here at Astrocon, so I was using the notes quite a bit. These two guys over here, over some beers at the last Astrocon, told me I should present, so here I am, giving it my best. So hopefully you all enjoyed yourself, and if you have any questions about this, I have business cards up the wazoo, and I'd like to talk to you guys about this. And there's always the Secret Society of Astros people, the mailing lists. Just go ahead and ask there as well. So thank you guys.